So today we'll discuss about the DC machine. Okay, so first of all, you should know about what is machine, right? Machine includes both the thing, it includes motor as well as it includes generator. Okay, can you tell me motor can convert which energy to which energy? Like you have a washing machine motor, yeah, you are giving electrical energy to the motor and you are getting mechanical energy from that, right? Similarly for the generator is converting which energy to which energy? We are giving mechanical energy and we are getting electrical energy, right? So we'll study about the motor and generator both in detail, what how it works. Okay. Now, first of all, machine or we can say motor is divided into two category. One is the DC motor, okay, and another one is the AC motor. DC motor is the motor in which we'll provide DC supply, okay, and DC supply means we are giving in the form of battery. We have given in the form of battery. Like you have seen DC motor also, that all the toys motor are the DC motors only which are used in toys. Okay, now AC motor is further divided into two categories. What are those two categories? One is the induction motor that comes under the AC motor, one is the synchronous motor. Okay, induction motor, what is the difference between these two motor? In induction motor, we can change the speed of the motor. Okay, let me give you one example of induction motor that you are using fan, right? So you can change the speed of the fan. That fan is of single phase induction motor. Okay, you have studied about what is single phase and what is three phase. So we are having single phase induction motor as well as for three phase induction motor. But at our home we are using single phase supply now. So at our fan we are using single phase induction motor and we can change the speed of the fan. Okay, synchronous motor speed is constant. We can't change it. Synchronous motor are heavy motors and we generally use it in industries. These are very big motors. Okay, clear? Now next thing you need to know about the concept which you have studied in the 10th class for any machine generator for construction. First of all, you should know that construction for motor as well as for generator is same, whether it is a motor or generator. Construction for both the motor and generator would be same only. What is the difference? There is a difference in working and principle only. Okay, so for every machine you will get have magnets like north and south, and for every machine you will have one coil which is rotating, right? These are the common for motor as well as for generator. Clear? So these magnets can be the permanent magnet if we want, and these magnets can be the temporary magnet, that is depending upon our requirement, what we require actually. Okay, so but there should be a magnet and there is one coil. Generally, they have shown a rectangular coil in the rectangular shape, but in machine we'll use generally the shape of circular. Okay, that I'll tell you in detail later on. So we are having two main things in this. Suppose we are working on motor. As I told you that motor is converting which energy to which energy? Now I'll teach you about the working principle of, yeah, motor is converting electrical energy to the mechanical energy, right? So we are providing which energy to the coil? Electrical energy, right? Means it is connected to the battery, correct? So we are providing electrical energy to the motor, means the current is flowing in this coil, correct? So you know that if there is a wire, current carrying wire, and if I place one magnet nearby to the current carrying wire, why I'm saying current carrying wire? Because current should be flow in that particular wire. So will there be any effect on the magnet or no effect? If you are having current carrying wire and you place near magnet to this current carrying wire, will there be if any effect on the magnet or not? that you must have studied in the 10th class. No, magnet can't rotate, it will attract or will repel. Okay, wire can't move, right? So magnet will attract or magnet will repel, that depends on the direction of current. So what does it mean? A current carrying wire always generates magnetic field, right? Current carrying wire always generates magnetic field. If you are having wire carrying current, then it is also having magnetic field, and if you are having magnetic field, then you will also have current. Okay, so this is the wire carrying current, it will generate magnetic field. Suppose here north pole is generated, so north and north will repel with each other, then in that case magnet will move away. And suppose if south pole is generated, then north and south will attract with each other, magnet will move towards the wire, correct? So this principle we have used here. In this also current is carrying wire, right? So here also the magnetic field is produced. Suppose north pole is produced according to the direction of current. Okay. So north and north, what happened? North and north will repel with each other, right? North and north will repel with each other. Now this coil is in rectangular horizontal position, like just you are holding your notebook in your hand, right? So if it will magnet can't move, so what will happen? This coil starts moving. Why? Because there is a force of repulsion, and if this coil will start moving, coil will hold this position, north here and south here. Okay, like just you are holding your notebook in the vertical position. Earlier you were holding your notebook in the horizontal position. Here is A, B, C, D, right? Now this AB parts move up, sorry, C, D. This AB parts move up and CD part will move automatically down. It will move, right? If you hold your notebook, it is in horizontal position. If you move it in the vertical position, one part will be up and one part will be down. So now in this case, north part will be up and south part will be down only, correct? Now you can see that here is the south pole. So north and south will attract with each other or will repel with each other. This here is a north pole attract, right? So north will attract the south. So now this coil moves completely 180 degree. Like earlier it was AB was here, but now at this condition AB was here and CD was here. Okay, so it completely flips. The coil completely flips, right? Just like you are holding your notebook, you come, it is in the horizontal position, then you move it in the vertical like standing position, then again back to the horizontal position but in the opposite side. So see, you are providing which energy? You are providing electrical energy, right? And you are getting which energy? Mechanical energy. That coil starts rotating. Clear? This is the very basic principle of any motor which on which it will work. Clear this thing? Now next similarly we'll study about the generator basic principle, because it will help you in understanding the machine. Again for generator, I told you they will use magnet, that is north magnet and south magnet, and in between we are having one coil, right? And in this is the generator, so we are providing mechanical energy and we need to get electrical energy, correct? So again this is the coil A, B, C, D, but this time we are providing mechanical energy. Mechanical energy means we are rotating this coil like this. Okay, you can rotate it clockwise or you can rotate it anti-clockwise. That depends on you only. Clear? Now you know that there are magnetic field lines. Magnetic field lines, understood? That magnetic field lines, you studied that magnetic field lines will always move from north terminal to the south terminal, right? So it is leaving the north terminal and entering into the south terminal. South terminal. So this is also north pole and this is also south pole. So we can imagine that there are magnetic field lines across north to south, right? Like that. There are magnetic field lines move from north to south. This is completely imaginary because we can't see the magnetic field lines now. So this is completely imaginary. And if you rotate this coil, will these field lines be cut or not? Like just imagine there are few lines okay, and you have placed coil in between. Just use your imagination. Okay, you have placed one coil in between, and you starts rotating this coil, right? So will this magnetic field lines cut or not? They will cut, right? So according to Faraday's law of electromagnetic induction, you have heard about the Faraday's, right? He is a very great scientist. His contribution in electrical is very big. So Faraday, what he says, that is E is equal to minus n d phi by dt. What is E here? E is the EMF induced, okay? N is the number of turns, okay, and d phi by dt. D phi by dt means that is change in flux with respect to time. Okay, change in flux with respect to time. D phi by dt. Phi is what? Phi is the flux. Okay, phi is what? Phi is the flux. And what is flux? Flux is the field lines. Flux is what? Flux is the field lines. Okay, so just related, phi is what? Flux, and flux is the field lines, means change in field lines with respect to time. So what Faraday stated, that if there is any change in the field lines with respect to time, then in that case EMF will definitely induce. Okay, EMF will definitely induce. So now just imagine that these are the field lines. You are rotating this coil. Will these field lines cut? I asked you earlier also. Will these field lines cut by rotating this coil? Yes or no? Yes. So if this field line cut, that will change also, because it will change, like it will in the horizontal, it would be, it forms 0 degree angle. If it in the coil is in the you will like 45 degree, then the value of flux will change. If it is on the 90 degree, then also value of flux will change. So whenever we'll start like rotating this coil, suppose just manually you are rotating by your hand, and this field lines will definitely cut, and if this field lines will cut, then the field lines will change also, right? And if field lines will change, that Faraday says that flux will change, and whenever there is a change in flux with respect to time, then in that case EMF will induce. Okay, then in that case EMF will induce, and EMF induced in this particular coil. EMF induced means they will get the voltage, and will get the voltage means there is a flow of current in this coil, right? Voltage is induced. EMF means you can consider it as a voltage only. So in this case voltage is induced. And see which energy you have given, mechanical energy, but which energy you are getting, electrical energy, right? Which energy you are getting, electrical energy. So it is based on the Faraday's law of electromagnetic induction, that is famously known as Faraday's law of EMI. Okay, clear this thing? Now Faraday gave two law. Okay, you should know the Faraday's law. Faraday's law. So we are having first law, we are having second law. Okay, what was the second law which I just told you, that the E is equal to N, it is minus actually, minus n d phi by dt. What does minus sign indicates? That suppose if we applied voltage in this particular direction, first positive then negative, then we'll get induced EMF in the opposite direction, first negative then positive. Okay, so negative signs just represent the change in the direction. So second law is this, that if there is any change in flux with respect to time, then in that case EMF will induced. Okay, clear this thing? So on the basis of this, he gave also Lenz's law. Lenz's law states that it is negative. Okay, Faraday just states that it is E is equal to n d phi by dt. E is equal to n d phi by dt. But Lenz's is a scientist name. He told us that it is not positive, but it is the negative. Clear this thing?